Hi everyone, thanks for clicking and welcome back to my channel. As per a request from one of you guys, I'm making today's video about METARs. So if you would like me to cover any aviation related topic, feel free to leave your suggestions in the comment section below and I'll be more than happy to make one for you guys. And as usual, I would highly appreciate if you could consider helping the channel grow by subscribing. So without any further ado, let's jump right into it. First things first, METAR stands for Meteorological Airdrome Report. It is issued usually automatically every 30 minutes, sometimes every hour. It depends from airport to airport. Before we get to Decode METARs, we will start by some very simple and basic METAR, then we move on to more complicated ones. Okay? Let's look at this one right here of London City Airport. First, we have the four-letter airport ICAO code, EGLC, followed by the date and time of issuance. In our case, the 29th of the month at 1350 Zulu. You can think of Zulu time as UTC. They are pretty much the same. Please keep in mind that all times in aviation are in UTC. Alright? As we said in the beginning of the video, METARs are issued every 30 minutes. So if you may expect the next report to be issued at 1420 Zulu, 30 minutes later. Next, auto. Auto signifies the report was issued automatically. The data is collected automatically from various components and measuring devices and published again automatically without the need of a human forecaster. Alright? Next, wind direction and speed. One very important thing you must keep in mind at all times is that winds in METARs and TAFs are in true north, not magnetic. Therefore, if you are operating into or out an aerodrome where the magnetic variation is large, you may need to apply the magnetic variation to obtain wind in magnetic north. Okay? Back to our example. The wind here is blowing from 240 degrees true at 5 knots. The letters Kilo Tango stands for knots. Sometimes you may come across wind speed reported in meter per second, like in China or Russia, for example. If that is the case, a very good rule of thumb to convert meter per second to knot is to simply multiply by 2. So 5 meters per second is simply 10 knots. Moving on, 180V260. Basically means that the wind direction is varying between 180 degrees and 260 degrees. When the wind varies by 60 degrees or more, but less than 180 degrees, the two extreme directions are mentioned with the letter V in between. However, at times the expression VRB is reported. This means that the wind direction varies by more than 180 degrees and usually between 2 to 5 knots in speed. Alright? Next, the visibility group in meters. 9999 also might be read as all the nines. Means visibility of 10 kilometers or more. If it is 5,000, it means visibility of 5 kilometers or 5,000 meters, and so on. Moving on to the cloud group. There is no cloud reported, so the code NCD is mentioned, which stands for no clouds detected. We look at another example where there will be clouds. Next is temperature and dew point. Also, the first digits are always temperature followed by dew point. So here, the temperature is 3 degrees Celsius and dew point is 0. The letter M, however, means a negative value. Whenever the temperature or dew point are 0 or lower, the letter M will precede to signify that the value is negative. Alright? Now, if you are wondering what's the objective of dew point, wouldn't only the temperature suffice? Well, knowing the dew point as well gives an idea of the humidity in the air. Also, whenever the temperature and dew point spread is small, or even when temperature and dew points are equal, that means there is a very high chance of reduced visibility due to saturation in the air. Of course, this isn't the only determining factor, but it helps with the bigger picture. One more takeaway from the temperature and dew point spread is that we can guesstimate cloud base based on that. For instance, say we have a temperature of 11 degrees Celsius, dew point 8. The temperature spread is 3 degrees, right? So 3 times 400 is 1200 feet or 1200 feet. Should there be any clouds in the area, there will be at 1200 feet AGL, more or less. Okay? And then, last but not least, QNH. 1015 in this example, this is the sea level pressure setting in hectopascals. This is the value we set in our altimeters so that we can read our altitude above sea level. Depending on the pressure system in the region, this value can vary from anything between 970 hectopascal all the way to 1035 hectopascal, sometimes even more. Alright, I guess that was pretty straightforward. So now that we have seen the basic METAR, let's move on to one that is a little bit more complicated. Before we do that, keep in mind that the structure is basically the same, okay? So we have the second example, JFK, or John F. Kennedy Airport. Again, the first four letter code are the ICAO code of the airport, followed by the issuance date and time, 29th of the month at 13:51 Zulu, or UTC. Wind is blowing from 310 degrees at 12 knots. Again, degrees are in true north. Visibility is 10 statute miles. Notice here, unlike the rest of the world, the visibility in the US is given in statute miles. Next, the cloud group. Few clouds at 3,800 feet AGL, above ground level. Always remember that the cloud heights come in 3 digits. The first is 10 of thousands of feet, then thousands, and the last digit is hundreds. Okay? Next, scattered cloud at 12,000 feet, and again, another scattered layer at 25,000 feet. The difference between few, scattered, broken, and overcast is as follows. If we divide the sky into 8 parts, or in Greek, 8 octas, if there is no cloud whatsoever, then the code sky clear, or SKC, will be reported. In some parts of the world, NCD, or no clouds detected. Either way, they both mean the same thing. If 1 to 2 octas of the sky is covered, that means few clouds. 3 to 4 octas, scattered. 5 to 7 will be broken. And if all the sky is covered, overcast will be reported. Next to it will be the at which altitude. Okay, moving on, the temperature and dew point group. Temperature is 4 degrees, temperature, dew point, -3. So a negative value, that's what the M stands for. Next is the QNH. In the US, however, they don't use QNH, they use the altimeter setting based on inches of mercury. In this case is 2990 inches of mercury. Okay. Next is something we did not see in the first METAR, which is the RMK. It stands for remarks. The first remark is the Alpha Oscar 2 or AO2. This refers to the type of weather measuring equipment, more specifically precipitation discriminator sensor, meaning this device is capable of reporting the type of precipitation, whether it is raining or snowing or so on. If it were AO1, for example, means all the sensor can tell is that there is some sort of precipitation. As of what it is unable to tell. Okay? Next is SLP124. The SLP stands for sea level pressure. And then the 124, you can just simply add 10 before that, and it will be 1012.4 hectopascals. Always the last digit will be the digit after the decimal. All right? Moving on to the last group, here's the unrounded exact temperature and dew point. Do we really need to know about that? Well, that's debatable. Okay, so T, easy, stands for temperature, right? Then the first 0 indicates that the temperature is a positive value. And if it were 1, would be a negative value. In our example right here, temperature is positive because of the 0. And the temperature, the exact value is 3.9 Celsius. Dew point, however, is negative because of the 1 right here. Then it is a negative 3.3 Celsius. Alright, I hope this explanation was helpful for you guys. Thank you again so much for watching, and if you have any questions or if you would like me to make any video about a topic that you might be struggling with, please feel free to leave your request in the comments. And as always, until the next video, see ya.